Hello friends. So today we will be discussing about the design how to. So today we will be discussing about the buck converter. So how buck converter works in the continuous conduction mode and boundary conduction mode. So we will be discussing this in detail. So first let us draw the buck converter. As we know buck converter, here is the switch, here is the inductor. We are having diode here, one capacitor here, load here. We are considering the resistive load. This is input voltage V in. We will considering the output voltage V naught, resistor R, capacitor C, and inductor R. The voltage across inductor VL, current across capacitor IC, and this will be the inductor current IL, and this is I naught. This is switch. It may be MOSFET, IGBT. So we will be considering that the buck converter is working in steady state. So considering converter in a steady state. So considering there will be two cases. Case 1, case 2. Case 1, considering switch S is on, diode D is off. Case 2, switch is off, diode is on. So when switch is on and diode is off, so circuit will be like this. This will be open, inductor will be here, capacitor, load, input voltage. So from here we can see that the blocking voltage of the diode, it will be V in, and this V in voltage will be appearing here, and this is V naught. So applying KVL, minus V in plus VL plus V naught equals to 0. So from here VL equals to V in minus V naught. In this case what will happen? Switch will be off, capacitor, this will be a load, from here this is the ground point, so this will be the 0 volt. The voltage across switch will be Vs, so Vs will be equals to V in. Now voltage across inductor VL, this is plus minus V naught, so minus VL minus V naught equals to 0. So VL equals to minus V naught. As we know VL equals to, if we apply any voltage across inductor, that is equals to VL equals to L d IL T upon dt equals to V in minus V naught. So this over the time integration d IL equals to, let us consider this is I min, IL min, IL max is a V in minus V naught by L integral dt from 0 to dts. So IL max plus IL min will be equals to Vn minus V naught by L into dts minus 0. So considering IL minus IL min is delta IL equals to Vn minus V naught by L dts. In case 2, what will happen? L dIL of t over dt equals to minus V naught. So dIL of on dt will be equals to minus V naught by L, and by integrating both sides dIL, this will be from IL max to IL min to minus V naught by L integration dt from dts to ts. So it will be IL min minus IL max, it will be equals to minus V naught by L into ts minus, we will write in the below, so minus V naught by L to ts minus dts. So it will be minus delta IL equals to minus V naught by L to 1 minus dts. So delta IL will be equals to V naught by L into 1 minus dts. So now applying volt second valence across the inductor, so uh, so VL into dts plus VL to 1 minus dts should be equals to 0. So VL into dts, so VL in dts time period is Vn minus V naught dts plus minus V naught 1 minus dts. So it will give V in dts, so V naught dts minus V naught to ts plus V naught into dts equals to 0. So from here we will have V naught equals to V into d. So V naught by V in equals to M equals to D, where M or V naught by V in is voltage conversion gain or voltage gain. As we said that converter is operating in steady state, so whatever the current is flowing in the inductor should be having some average value and some ripple current. Let us say IL equals to IL average plus delta IL. Now in so we will be drawing the inductor and waveform first. This is IL min, this is IL max, and this will be something IL average. That will be equals to I naught in buck converter. We can see that in capacitor or current, or can say uh, ampere second across capacitor should be followed. So according to that, uh, IC over time period Ts should be equals to 0. As we can see that IL, from here we can see this IL current. This IL current is basically the sum of I naught plus IC. So IL equals to I naught plus IC. So as we know that IL average equals to I naught average plus VC average. So we can see that IL average equals to I naught average. That is simply equals to I naught current that is flowing through the load. So now we are considering that inductor is that circuit is operating in continuous conduction mode. If we consider that for finding the for design purpose, we need the uh, value of inductor and capacitor for the designing of buck converter. So we will be going for the designing of inductor and capacitor. Now when in continuous conduction mode we are going, so in continuous conduction mode what will happen that current across conductor will not become zero. If current across the inductor becomes zero, so it will buck converter will start working in discontinuous conduction mode. So we will be going for the calculating the value of L and C. For designing, we are considering the boundary conduction mode. In boundary conduction mode, what will happen? This ripple current, this is ripple current, that is delta IL, will be equals to uh, IL average divided by 2. Like what will happen when we are considering boundary conduction mode? This current, this IL minimum will equals to 0. When IL minimum will be equals to 0, then what will happen? The waveform will be like this. This will be IL max. This is IL average. So in BCM, that is boundary conduction mode, IL means delta IL will be equals to IL by 2, IL average by 2, that is equals to I naught by 2. Sorry, uh, I made a mistake here. So IL average will be equals to delta IL by 2, that is equals to I naught. So from this above expression we will be taking this expression for finding the value of inductor. We can also use this expression. So I naught equals to delta IL by 2, that is equals to V in minus V naught by L into dTs into 1 by 2. As we know, I naught equals to V naught by R. V naught by R equals to V in minus V naught by L dTs into 1 by 2. As this V naught equals to dV in, so what we will do, V in minus dV in by L dTs into 2. This is V naught by R. So from here also we can do V naught equals to dV in. So this will be dV in. This d will cancel, and V in by R equals to V in 1 minus d divided by 2L into T of S. So this V in will cancel, and from here we can find L equals to L critical equals to R 1 minus d divided by 2 into T of S. This is the searching time period, so it is inverse of frequency, so we can also write R into 1 minus d divided by 2f. This is L critical. Why I am saying this is L critical? The L critical means here, like if the value of inductance is less than this L critical value, then what will happen? This inductor current, uh, this inductor current average will fall below the delta IL by 2 value. So what will happen? It will go into discontinuous conduction mode.